Hello, children. It is time for a lesson on exponents and roots. So here we go. This is Unit 7. Oh, I don't like this pen already. Exponents and roots. Okay, let's try this other one. Exponents are shorthands mathematically, just kind of like multiplication is. 5 plus 5 plus 5 plus 5 plus 5 is a lot to write, so we simplified it, saying, well, that's 5 times 5. So 5 5s added together is 25. This is shorthand for adding. Exponents are shorthanded for this exact same type of multiplication. 5 times 5 times 5 times 5 times 5. So it's still 5, but it's not times 5. It's now to the power of 5. The exponent makes you multiply this number by itself that many times. So 5 times 5 is 25. This is something big. So that's a big number. Let's see. It's like 25 times 25 times 5. So, oops. 5 times 5 times 5 times 5, that's 4, plus one more is 3,125. That's what exponents really do. They make you multiply the number at the bottom. Let's give that a name. The number at the bottom, in this case, it was 5, is known as the base. The exponent sits right here. Floating up, always on the right side of the base. Of course, you know that the power of 2 has the name squared, and that's because if you make a square, and it has the sides of 5 and 5, it gets the same answer as 5 times 5, or 5 to the power of 2. It's 25. That's why we call it squared. It has the same value. Any number to the power of 2 is the same as a perfect square with a side length of whatever that base is. Cubed is to the power of 3. And that's because if you make a cube that has 5 as its dimension, it's 5 times 5 times 5. That's 125. And that's why it has a special name. The power of 4 doesn't have a special name. Nothing else has a special name. Just power of 2 is squared, power of 3 is cubed. Of course, we can put exponents on variables. I can have x times x times x times x times x times x. And I'd say, well, I'm going to keep that base right there of x. How many x's did I have? 1, 2, 3, 4, 5, 6. To the power of 6, right? So you can have any symbol, you have pi, right? Pi times pi times pi times pi. It's going to be, that's 4 pi's. So pi to the power of 4. Right? So this is expanded form right here where things are written out. So if I did 9 cubed, and I wrote it out as 9 times 9 times 9, that's expanded form. This is exponential form. So I can give you this and say, give me it in exponential form, and you write it just like this. Of course, if I ask you to solve it, you'd have to do whatever 81 times 9 is, that's 729, right? So that's the solution. That's what either of these equals. This is expanded. This is exponential. Those are the two forms. Okay? So let's look at some patterns that we see with exponents. Okay? So I'm going to start with squares, right? we'll make a perfect little square chart. So we have like 2 squared, you know that's 2 times 2, that's 4. 3 squared, 3 times 3, that's 9. 4 squared is 4 times 4, 16. 5 squared is 5 times 5, and that's 25. 6 squared is 6 times 6, and that's 36. These are your perfect squares, right? You know all these. 7 squared is 49. Oh, I forgot 1 squared, sorry. 1 squared is 1. 8 squared is 64. And 9 squared is going to be 81. Now, there's some cool patterns that you'll see in numbers that have the same ones digit. So I'm going to do the next 10 right here. Well, 10 squared, of course, would be, let's do 0 squared down here. I'll put the 10 at the bottom. It'll look weird, but that's fine. 0 times 0 is 0. So 10 squared is going to be 10 times 10, that's 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. I always remember these two because it's the same numbers switched. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324, I believe. Ooh, I'm blanking. Let me double check. 18 squared is 324, yay. And then 19 squared can be 371, I think. I'm blanking, I haven't done this in a while. 361, there we go. Okay. So, now you don't have to memorize these. You can always use a chart. You can always refer back to these. But I wanted to just show you that there are patterns that you'll use later when we do what's roots. Everything in math has a opposite. So raising something to a power is making you multiply that base to get a product. Taking a root will say, well, what number squared is going to give us 81? So these patterns will help you figure things out when we get into the upper digits. So if you notice that nines, anything that ends with a 9, it's going to end in a 1. See, 9, 19, it ends in a 1. Same with ones. Anything that ends with a 1, ends with a 1, right? Anything that ends with an 8, so 8, 18, 28, they're going to end with 4. Same thing with 2s. 2, 12, 22, ends with 4. Now, of course, 9 and 1 make 10. 8 and 2 make 10. 7 and 3 make 10. And guess what? They have the same last numbers. 7 and 17, 27, they end with 9s. 3, 13, 23, 33, they're also going to end with a 9 in the ones digit spot. 6 and 4 make 10. Well, you got 6 and 6. For the 16, ends with a 6. 14 ends with a 6. And this goes through all of time. Every single number you get, it always matches this way. And so one of the things people do to find the roots is to estimate it, to kind of guess, we look at the tens, and I'll show you that in a little bit. I just wanted to show you that that's one pattern. I'm going to show you a different pattern with perfect squares, or not with squares, but with growing powers. So let me start with the base of 2. We're going to do 2 squared. That's 4. Keep the base, but I'm going to go up to the next power. 2 to the third power, or 2 cubed, is 8. 2 to the fourth is 16. 2 to the fifth is, what's 16 times 2? That's right, it's 32. So 2 to the sixth power is going to be 32 times 2, which is 64. 2 to the 7 is double that, so that's 128. And 2 to the eighth is, what's that, 256? You may recognize this as also 16 squared. Ooh, that's kind of fun because 2 4s twice, 16, 16, 16 squared, same stuff, fun stuff. Here we go. 2 to the power of 9 is going to be 512. And 2 to the power of 10 will be 1028. If you've ever played 2048, which is the next one, 2 to the power of 11, 2048. If you've ever played that game, you'll recognize this pattern of numbers, right? So every time it goes up, it doubles. But also every time it goes down, it's being cut in what? It's being cut in half, right? Half of 512 is 256. Half of 256 is 128. Half of 64 is 32. Half of 16 is 8. Half of 4 is 2, right? So 2 to the power of 1 is 2. Every number to the power of 1 is just itself. Now, here's the trick, though. 2 to the power of 0. Your instincts are going to say 0, right? And that's because anytime you've used 0 in any kind of multiplicative way, it's always 0. 0 is a special case. But let's look at the rules, because in math, patterns don't deviate. They follow their pattern. It's being cut in half each time. So if half of 8 is 4 and half of 4 is 2, half of 2 is what? That's right. It's 1. 2 to the power of 0 is 1. And what you'll see later, in a later lesson, I'll prove to you why anything to the power of 0 is just 1. Right now you have to trust me and try not to get too tripped out by the next one. 2 to the power of negative 1. Now, of course, you're going to go with your instincts and say, well, it's going to be like negative 2 or something because we got a negative. But that's 2 times negative 1. We know it can't be the same. 2 times negative 1 and 2 to the power of negative 1 shouldn't be the same answer. Let's go with a pattern. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is 1/2. I'm going to come back up here and I'm going to write the next one. 2 to the negative 2. Well, half of a half is 1/4. And if I do 2 to the negative 3, half of a fourth, well, half of a fourth is an eighth. It's like pizza, right? So what do we see here? First thing was that anything to the power of 1 is just that number. We found that anything to the power of 0 is just 1. And in this case, with the base of 2, anything to a negative power made a fraction, and each one went down by a half. But if we look at this, another way we could write 1/4 is really 1 over 2 to the power of 2. Because 2 to the power of 2 is 4. And 2 to the power of 3 is 8. So 1 over 2 to the power of 3 is really 1/8. So what the negatives are doing negative exponents make fractions. It puts 1 in the numerator and whatever it is in the denominator. So if I have, let's say, 8 to the negative 7, well, it's going to go down here and be 8 to the 7th power. I'm never going to make you figure that out because it's a really big number. But that's what a negative exponent does. It takes it down. So if real quick we use a different base, like we do 3 squared is 9, 3 cubed is 27. 3 times 3 is 9, times 3 is 27. 3 to the power of 4 is already 81. 3 to the power of 5 is this times 3, so 243. And one more, 3 to the power of 6 is 729. Now, this is tripling each time it goes up. So each time it goes down, it's being divided by 3, right? It's being divided into thirds. So 3 to the power of 1, a third of 9 is going to be 3. And 3 to the power of 0, well, a third of 3 is 1. See, again, following its pattern, it matches. Anything to the power of 0 is 1. Remember, I'll prove that to you later. 3 to the power of negative 1, well, that's the same as 1 over 3 to the power of 1. Or divide that 1 by 3, we get a third. 3 to the negative 2 power, it's going to be 1 over what? Well, negative 2 is going to be the same as 2, so it's 9 on the bottom, and 3 to the power of negative 3 is going to be 1 over 27. See how they match? There's always patterns. If we went to the 4s, it'd be the same thing. Whatever 4 to the power of 4 is, which is actually 256, you'd have 4 to the negative 4 would be 1 over 256. Whatever the positive exponent would be is the denominator of the negative exponent that matches. Okay? This is a lot, but you can do it. So, here's what we're going to do. We're going to practice for a second. Okay? So, I got a practice sheet for you here. Here you go. This is the top half of the worksheet for this lesson. Find the product of the exponent practice. So you'll see I start out with squares, use a calculator of course. I raise up to some higher powers, and then 4 negatives to end it. So remember, you're going to get fractions in the end. Pause the video and then we'll go over that. Okay, here we go. 8 squared is 8 times 8, so that's 64. 14 squared is 14 times 14. You should have gotten 196. 19 squared, well, that was 361. And 25 squared is 25 times 25, which is 625. Yes, I have those memorized. 6 cubed is 6 times 6 times 6. So 36 times 6, which I know is 216. I start to forget these soon. Okay. 6 is 2 to the power of 5. So 2 times 2 is 4, 8, 16, 32. And yes, I use my fingers every time I do those. 4 to the power of 4 is 4 times 4 times 4 times 4. Oops, weird looking 4. So that's really 16 times 16, and I know that's 256. 10 to the power of 6, that's 1, 2, 3. So it's going to be 6 zeros. So 1, 2, 3, 4, 5, 6, and a 1. So 1,000,000. All right. 10 to the power of 6 is 1,000,000. Okay, and moving on. I've got 2 to the power of negative 3. So that's the same as 1 over 2 to the power of 3. Because the negative makes it go down into the denominator spot. And 2 to the power of 3 is 8. So 1/8. 4 to the power of negative 2 is 1 over 4 squared. 4 squared is 4 times 4. So 1 over 16. 11, 3 to the power of negative 4. It's going to be 1 over 3 to the power of 4, which is going to be 9 for the and times 9. So 1 over 81. And last, 10 to the power of negative 5 is going to be 1 over 5 zeros, right? 1, 2, 3, 4, 5. Boom. 100,000. There you go. So those are practicing exponents. Let's move on. Okay, let's go backwards now. Now, one thing I want you to refer back to is if you wrote this down, this sheet of perfect squares, please refer to it. If you don't have it written down, you might want to pause it and either take a picture on your phone so you can glance at it or just copy it down, at least the ones you don't know. I mean, I'm sure you know 5 times 5, right? So just do those if you need them. So we're going to find the root. Now, the square root is this symbol all by itself. On your homework, it just looks like this because the computer doesn't have it go all the way, so the numbers are sitting right there. But no, it's the same thing. This is called the radical sign. I guess it'd be a radical jump if you jumped your bike off the cliff, or were able to jump up. So the number inside is what we're looking for. So if I put 9 in here, it's saying what number times itself, or what number squared, is 9? Well, you know that's 3, right? So the square root of 9 is 3. And the square root of 36 would be what number times itself. Remember, it's always a whole number, unless I put a decimal. We'll talk about those in a second. 6 times 6 is 36, so the answer is 6. Now, here's the thing. Every square root actually has 2 answers. I'll say that again. Every square root has 2 answers. And you'll say, wait a second. No other number times itself is 9. Only 3 times 3 is 9, correct? So if you know it's going to be 3 times 3 to make 9, what else can you do to that 3 to make it similar but not exactly the same? That's right. Hopefully you thought, well, I can make it negative. Because a negative, if you remember our little Yoshi wheel, a negative times a negative is a positive. So when you square negative 3, you're going to get positive 9. When you square negative 6, you get 36. So anytime you take a square root, we know that 7 times 7 is 49. So you're going to write that 7. But since there's two answers, you could say it 2 ways. You could either write 7 comma negative 7, or do what I do, which is I put the positive and negative sign in front of the 7. It's saying both positive and negative 7 squared will make 49. That makes sense? So no matter what I give you, you're going to have to think about what number times itself is going to be that number, and then give me this symbol. So if I give you 225, first thing I want you to do is I want you to look at that end number. It ends with a 5. So what number times itself is going to end with a 5? And you should say, well, something that ends with a 5. You know, 5 times 5 is 25. And 15 times 15 or 25 times 25 are your next possible options. Now, 25 times 25 is a big number because it's bigger than 400, because 20 times 20 is 400. So you're going to say, well, that's obviously 15, even if you don't know that, although it is on your chart. Put the positive and the negative, you're done. Cool? So some of the things I do to make this a little more challenging, of course, is I can give you, you just do one for fun. I shouldn't just throw it all out there. Let's do 256. Take the square root of 256. Look on your chart and you'll find the answer, I bet. You can say, oh, that's 16, right? So your answer will be positive negative 16. But I can also do something like this. What's the square root of 1 over 64? You'll say, well, that's a fraction. I don't know. Well, the answer is it's going to be a fraction times a fraction. So what number times itself is 64? You can say, well, 8, right? What number times itself is 1? 1. So positive and negative 1/8. I could also do something like this. I could do 25 over 81. So basically what this does is it gives you 2 separate problems. They're not really linked. It's just numerator gets solved and the denominator gets solved separately. So what's the square root of 25? Well, that's 5. Square root of 81, 9 times 9 is 81. So it's 5 over 9, both positive and negative. Does that make sense? Let's hope so. Let's do decimal versions of the same kinds of things. And we'll start right here with something that I think you will recognize. The square root of 1.44. Now ignore the decimal. You know that number is 144. And you also know that 144, its square root is 12. So here's the thing. Whenever you have decimals, they're always going to be even. Because no matter if there's one decimal in each number, that's going to make 2. If there's 2 in each one, they make 4. You can't have one with 2 decimals and the other one with 1, because then they're not the same number. So any number squared will just double its decimals. So there's 2 numbers past the decimal, so half of 2 is 1, so there's 1 decimal space here. Does that kind of make sense? Let's take the square root of 3.61. If you go and you look at the number chart, you found that it was 19. 19 squared is 361. There's 2 decimals, so there's only 1 there. See? It's not that crazy. I'm going to give you one you may not know, and I'll help you figure this out real quick. Here we go. So, we're going to find the square root of 10.89. You're going to say, I don't know that. But here's what we're going to do. I'm going to refer you back to this chart where we had the 10s. Well, if we had the 20s, you would see, well, they're in the 400s. If we had the 30s, you would say, well, they're not all in the 400s, but they go from 400 to basically just below 900. So we look here and we say, well, this is just a little over 900. It's 1,089, right? So this is going to be in the 30s because it's between what 40 squared would be, which is 1,600, okay? So since it's between those, we know it's in the 30s, and it ends with a 9. So go back over here and say, well, things that end with 9 are either going to be a 3, like a 23, or a 33, or they're going to end with a 7. So it's either 33 or 37. Now, if you look at this and say, well, 37 is going to be a lot closer to 40, so it's going to be a lot closer to 1,600. 33 is a lot closer to 30, so it's going to be closer to 900. And so your guess would be this is 33. Half that, and you get 3.3. Now, of course, it's easy to check. Just go 33 squared. If you have that on your calculator, you should. Yep, it's 10.89. My cat's somewhere meowing. Anyways, so here you go. Here is finding the root practice. All right, so pause that, and we'll solve it. Okay, so all 12 of these are done. Let's get this done, and then you're done with the lesson. Here we go. The square root of 9 is going to be 3, because it's 3 times 3. It's both positive and negative. Number 1 is done. Number 2, the square root of 36 is going to be 6, because 6 times 6 is 36, both positive and negative. Square root of 64, 8 times 8 is 64, so it's both positive and negative 8. On the chart, you saw that 14 times 14 is 196, so this is both positive and negative 14. And I come over here, and I see that I wrote the square root of 289. And, off the top of my head, well, it's bigger than 14, and so it's in the teens. So it's got to be a 17, right? Because it ends with a 9. So that's going to be positive negative 17. So square root of 900 is going to be, well, the square root of 9 is 3, and there's 2 zeros, so 1 0 here. Positive and negative 30. The square root of 1 over 49, well, it's going to be 1 on the top, and the square root of 49 is 7, so positive. Negative 1/7. 18, I have 1 over 16, so 1 over 16 is going to be 1 over, well, 4 times 4 is 16, so positive and negative 1/4. 0.25, well, I know 5 times 5 is 25, and there's 2 decimal spaces, so it's going to be 0.5 or 0.5, whichever, positive and negative. Number 10, I see 121. I know that's 11 times 11. 2 decimal spaces, so the decimal is going to be in the middle. That's kind of hard to see. 1.1, sorry. Positive and negative. 625, you may have seen on the chart, was the 25 squared, so 2 decimal spaces, so 2.5, positive and negative. The last one, number 12, 0.04. Well, to get 4 squared, you need a 2 decimal spaces, so 0.2. So either 0.2 or 0.2. All right, so those are exponents and roots. You're going to have homework number 5 to do. Hope you guys are doing well. Talk to you soon.